All right, we're now working in to section 2.2 and hopefully 2.3. We'll see how far you guys can get today in class. I will record it in two separate videos so that you don't have to kind of scroll through this one video. So this will cover 2.2, the algebra of functions. And I think this is kind of a review for a lot of you as far as like what you can do, inputs and outputs, and using the actual function itself, not the graph. But we'll head into graphs next, okay? So I want you to try this as a warm-up. Tell me what the input is, where the input goes, in what function, and what do you get as your output. And then list it as a point on the graph. So we are going to do one together. So f of 1 is the input is 1. It's going to go into this f function, 2x minus 3x squared. So it's going to go like this, 2 times 1 minus 3 times 1 squared. And then simplify that using PEMDAS. I'm not a ton of work because this is a value of 1. So 1 squared is 1 times 3 is still 3. So the output would be a negative 1. And the point on the graph would be 1, negative 1. So press pause, and then I will have this whole table filled out once you press play again. All right, so I hope that you guys got what I have on the table. There could be some questions, so if you have any with Mr. Kakutani, go and ask. I could have also made a mistake here, so if you guys see it, make sure you point that out. Okay, moving on to the next. Oh, a couple of things I want to point out. If you look at the last two, the x plus 1, I FOILed it out and combined like terms, so I got this here. In terms of x now, it doesn't have a, it still has that variable x in there. So your answer will have x in the coordinate points. And same for g, there is an x and an h in there, so it really doesn't simplify that much more. But remember, your input is going to replace wherever you see x. So even though it has an x plus 1 in there, this is going to change into x plus 1. And so there's still a 2 that needs to be multiplied to x plus 1. And same like this one, this is going to change into x plus h right inside there, okay? So that's a little more abstract, a little bit harder. That was a reach type of problem, okay? So if you can understand that concept, that's applying it even further. Now the next question down below is g of x plus h the same as g of x plus h? It looks like it could be, but it is not. Sometimes it's true, especially if your g of x doesn't have any x in there. You can just add h after. But if it has x in there and it has multiple x's, like x being squared or x times by 2, it's not going to be the same because you have to times the h as well by that 2, or you have to square the quantity x plus h. So no, they are not the same. G of x plus h, the input is x plus h. G of x plus h, add h after input of x. Okay? So just be careful what that really means. It's not something that you distribute or have after. Functions are inputs and outputs. Okay, so now we're going to look at it on a graph. We have it looks like an absolute value graph. P of x is shifted up 1. It's like not starting at 0 anymore, it's starting at 1. The way that we can do algebra with functions graphically is you look at the input and the outputs, and you can actually add them. This is the same as saying P of 1 plus H of 1. Add them separately. So what are the outputs at 1? And then you're going to add them together. So P of 1, here's 1. It's going to be right there. that output is 2. Okay. And then h of 1, here's my h graph, that output is 3. So this is going to be 5. Okay, so take a moment, press pause, and complete the rest of these. And I will fill in the rest of the answers in a second. And then you can ask Mr. Kakutani if you have more questions on this example. All right, check your work with mine above. We have 4 for B, -9 for C. Some of you might have had -8, but this is the point that it intersects on the H graph. It's a little bit hard to tell at -5. And then D was just 2 times 3, which we used as the outputs for A, but you have to just multiply them. And then E, we have undefined because the denominator gives me an output of 0, where the numerator is going to be 3. Okay. Any questions? Please pause and ask Mr. Kakutani. All right, moving down to the bottom half of this page. What I would recommend is let's do C first, and then we can work on A and B a little bit more. So it's funny how that one's out of order in my mind. This is the same as saying f of 10 minus g of 10. And if I want to do it in terms of x, it would be f of x minus g of x. I guess A is pretty easy to complete, so maybe we'll just do it in order. F of x divided by g of x. So this is going to be just writing it with your functions in terms of x. Now just be careful, whatever you have for g, if you have more than one term, you have to minus all of g. Okay, so notice our g is 8x plus 5. It's going to be minus through the whole thing. So this is going to be the square root of x minus 3 minus, you can throw it in parentheses or distribute it along the way. It's going to turn to 8x minus 5. That's done. Now if I'm combining functions by division, you're going to write the top function over the bottom function. X minus 3 divided by 8x plus 5. Now just be careful whenever you write some kind of function with division, you're going to have 0 in the denominator. Yes, we got to make sure we don't have that in the denominator. So check for that. It's going to limit your domain. This one has a cool domain. We got 0 in the denominator, not super nice value. And we also have a radical, which limits our domain. And the last one, go ahead. You can even use the function that we wrote right here. And just evaluate at 10. It would be the square root of 10 minus 3 minus 8 times 10 minus 5. So this is going to be the square root of 7. That's 85. And then that doesn't combine, so you can just leave it like that. That's as simple as it can be. Go ahead and pause if you need and ask questions. All right, so now we're going to go to this page on looking at a combination of f. So this line going up and to the right, being added with the combination g of x. And no, you're not supposed to know this function, but just to prime you, this is the sine graph function. Okay, that's called sine. Maybe I should write it like f of x. Oh, sorry, this is g of x. G of x equals sine of x. And then this f of x function is pretty much a straight line. Y equals x. So we have these two functions, and if I add them together, what are they going to look like graphically? Okay, so I want you to choose the one that you think looks the most like, if I were to combine them, what would they look like graphically? And you can use some skills that you've already used in the past. So meaning like you can add at certain points and then see what happens. So take a moment, figure it out, and then see. Press pause if you need. I like to pick nice points. So for example, the point that I would pick here would be 0. You see the outputs over there? 0 plus 0 is going to be 0. So I immediately can say that this is not the output for A. I can cross off A. B looks like it's still there. D looks like it's still there. And C also looks like it's still there. So I can only eliminate A at this point. Another nice point I see on the graph is the at 3. If you look at 3 and I add those two values together, I get 0 plus 3, and I get 3. So my output should be 3 at 3. 1, 2, 3, 1, 2, 3. That one works. You see that? If I go 1, 2, 3, 1, 2, it's not there, yeah. So I can cross off D. And how about C? 1, 2, 3, 1, 2, 3. That C is also not there. So what do we want to say for C and D? Let's just be sure that it is B. By picking one more nice point on B, I like this x value of -3, and that output is 0, and that output is -3. So at -3, my output should be 0 plus -3, which is there. And it does kind of look like the graph there if I were to add them together. Yeah, if you see one of them is increasing along the interval, the other one is oscillating. So when you add it, it's going to be increasing and waving at the same time. So yes, B is the correct answer here. So if you chose B, nice job. And then we're going to go into talking about when we add, subtract, multiply, and divide functions. We have a limited domain, especially when we are dividing functions, okay? So anytime you limit your domain, you're going to find that when you add or do any kind of combination of functions, it's where the domains of all intersect, meaning like it's where it's true only for everything there, okay? Now, the other thing that we want to consider when we're dividing, I kind of just talked about that, f of x divided by g of x. If I have two functions and I'm dividing, I have to also think about when g of x is 0 because it cannot be 0, okay? So limit the domain by intersecting the two domains and also determining when the bottom is 0 if you have division. Okay. So intersection versus union, I'm just going to talk about the differences between the two. So we've seen this one already, but this is the actual meaning. The next one is called intersection, and that is where the domains have to be true for all. Okay, so what is different? So let's just say this is our domain -3 to 10. And then I have that domain going from here to here. Okay, I'm going to do some open circles. And then I have from 0 to 50. So it's going out some more. So 0 to, let's just say 50 is right there, not drawn to scale. And I have open circles there as well, and shade out everything in between. The union of these two domains are going to be where everything is included. It could be here or both. That's what union means. So it could be all of it. So the union looks like this from -3 to 50. Sorry, running out of room there. 50. So it go all the way across. That's my union. Okay? Now, if we're talking about intersection, the intersection would be only where both work. Okay? So we kind of did this already when we found domains. You can think back to that. Like, where do they both work? And you can only list that part. Okay? Where does it work? It doesn't work here. So I'm going to draw it again. We're going to line it up. So -3 to 10, 0 to 50. Where do they both work? So this is 0, and this is 50. The only place is like right there. Okay? Because this continues here, but it doesn't work there, and it doesn't work here. Where do they both work? It's just right there. Okay, so the intersection of the two domains would be only from 0 to 10. Okay, does that make sense? I hope that makes sense. So whenever you list domain, see where it works for both of the two functions. If you're using division, also see where the denominator is equal to 0, and then you cannot include that as well. Okay, that's the end of the the algebra of functions. we will do another video on composition of functions.